Okay, so like I said, we are going to be looking at limits as x increases or decreases without bound. So we're not talking about the y's increasing or decreasing without bound, it's the x's. So a limit at infinity specifies a finite value approached by a function as x increases or decreases without bound. Now here are some things we've already talked about. Any constant other than 0 divided by 0.0001 is infinity. And any constant divided by negative 0.001 is going to be negative infinity. But here's something new. Is that a constant divided by positive or negative infinity is going to be 0. Here's why. Anytime I take a constant, let's just take the number 2. If I divide it by a really large number, look what I get. That is very close to 0 because it's going to be 0.0002. So that's basically 0. Just to make it a little bit easier to see, let's take off a 9. See how that's getting closer and closer to 0? So the larger the number is that we're dividing by, then the closer we're getting to 0. So that's something we're going to keep in mind. So to evaluate the limit of a rational function as x approaches positive or negative infinity, first we should always just try substitution. That's what we do for every limit. Any limit we're trying to find, we first just try substituting in the x value. If that fails, okay, now up to now, the only time we've had a failing test on that is if we get 0 over 0 or a constant over 0. Here's another case. If we get infinity over infinity, that's called indeterminate, in addition to 0 over 0 being indeterminate. So if this happens, then here's what we're going to do. Divide each term by the highest power of x in the denominator, and then use substitution again. So let's look at some examples of how this is going to work. First, we're going to plug in infinity. What we're trying to do here is we want to know what's the y value approaching as x gets larger and larger and larger. So I'm going to plug it in. We're going to have 5 minus 2 over infinity. What did we say a constant divided by infinity is? 0, isn't it? So this is really going to be just 5 minus 0, so that's going to be 5. So let's look at what that really means as far as a picture goes. So if we're looking at the graph of this, 5 minus 2 divided by x squared, do zoom 6, here's the way the function looks. So this question is asking me, as x gets larger and larger, what is the y value we're approaching? Well, I could literally sit here and hold this button down until the end of class, and eventually it's going to say a certain number because it's going to be so close to it that it has no alternative. And what's the number that it's getting closer and closer to? 5, okay? So that's what it's asking us. X is going down to infinity. What is y approaching? And we can see that it's approaching 5. And that's what we just found. Okay? So on the next one, again, we try plugging in negative infinity this time. So this time it means x is going way down to the left. I try plugging in. 2 times negative infinity is negative infinity, minus 1 is still negative infinity. See, you can't do anything to infinity to change it. If I say you have infinity and I want you to divide it by 2, it's so large that dividing it by 2 does not matter. If I tell you to multiply it by 2, it's still just called negative infinity. Plugging into the denominator, negative infinity plus 1, that does not change anything. We still have negative infinity. This is indeterminate. It has no meaning until we do some more work with it. So what we have to do is, right here, if we get infinity over infinity, plus or minus on either one, divide each term by the highest power of x in the denominator. So look at the denominator. The highest power of x I have is x to the first. So I'm going to take each of these terms and I'm going to have to divide them by x. So see what I'm doing? This term got divided by x, got divided by x. every single term got divided by x. And now I'm going to simplify it, each term. So this term, my x's cancel, I get 2. This term, nothing cancels. This term, x divided by x is 1, and on this one, 1 over x. So we're trying to find the limit as x approaches negative infinity. So now, wherever I have an x, I have to replace it with negative infinity. So I'm going to have 2 minus 1 over negative infinity, 1 plus 1 over negative infinity. What did we just say up above about any number divided by plus or minus infinity? What is it? It's 0, isn't it? Any constant divided by plus or minus infinity is 0. So I have 2 minus 0 over 1 plus 0. That's just going to be 2. Those are both 0. Looking at this graphically, remember, our goal is to be able to do calculus without a graphing calculator. Some of you are going to go to colleges where they don't even let you use graphing calculators at all for calculus on any quizzes or any assessments of any type. So you have to know how to do calculus algebraically. The graphing calculator is just a tool we can use to help us to understand whether our answer seems reasonable. So I hit trace, and I want to know if x goes down to negative infinity. So as x gets smaller and smaller and smaller, what is the y value we're approaching? And so you can see that as this x is going down to negative infinity, if I just stop now, we might even think that it's going to just be like 2.14 or something. But the further down we go, we're going to eventually see it level out, and it's going to get very, very close to 2.0000. It's getting closer still. Okay? And so that's our limit. It's never going to go below 2. It will never be 1.999 or anything like that. It's always just going to get closer and closer to 2. Okay? All right, on the next one. So again, I want to plug in infinity. Negative 2 times infinity is infinity. Plus 3 is still going to be negative infinity. 3 times infinity squared plus 1 is infinity. So I have to do more work. What I'm going to have to do is divide each term by x squared this time. So I'm going to have negative 2x has to get divided by x squared. 3 has to get divided by x squared. Every term. Now we want to simplify. So this is going to be negative 2 over x. And our whole goal has been to plug in infinity for x. So now I'm going to replace my x's with infinities. So what is negative 2 divided by infinity? 0. So I'm now going to have 0 plus 0 divided by 3. What's that answer? Is it indeterminate or is it 0? 0. 0 divided by 3 is just 0. If I'd gotten 0 over 0, I would have had to do more work, but 0 divided by 3 is just 0. If you wanted to, you could graph it on your graphing calculator to check. All right, let's do example 4. Now I want to kind of tell you to skip some steps. Instead of rewriting this, let's try to think ahead. What is it that we're going to divide by? What is it, Paige? X to the second, right? It's the highest power of x in the bottom. So if we divide this first term by x to the second, I'm going to just get negative 2. If I divide that term by x to the second, I get 3 over x to the second. If I divide this by x to the second, I just get 3. And if I divide this by x to the second, I get x to the second. And so now I plug in the infinity, the negative infinity. This is going to be 3 over infinity squared, 3 over infinity squared. So what's that limit going to be, guys? Negative 2/3. If I typed it in and pushed it down, it would just keep approaching negative 0.6666 repeating. Okay, try this one. Always have to plug in infinity first. It's going to be infinity over infinity. So what am I going to divide by? X to the third or x to the second? X to the second. It's the highest power of x in the denominator. So I have to divide this term by x to the second. Well, that's going to still give me 2x. Divide that by x to the second. Dividing this by x to the second is 3. Dividing that by x to the second. So now I have to plug in infinity. So I'm going to have 2 times infinity plus 3 over infinity squared over 3 plus 1 over infinity squared. Well, what's 2 times infinity? Just infinity, right? So I've got infinity plus this would be 0 divided by 3 plus this would be 0. So what's this answer going to be? Anybody know? If we have 2 times infinity over 3, what are we just going to call that? I said you can't change it, so what is it? Infinity. What does that look like when our function's approaching infinity? Well, if I put this function in, and I want to see what happens to this function as we get closer and closer to x being infinity. I'm going to get this. I do my zoom standard. Okay, here's the way the function looks. I'm going to trace it, and I want to know what happens to the y value as x goes to infinity. So I push the arrow to the right because I want x to get larger and larger. Can you see what's happening to y? Where's the y value going? It's going way up, isn't it? Doesn't it just keep getting larger and larger and larger? See how it's going up the longer that I hold this down? I mean, it's not that big yet, but can't you tell that it's not leveling out to one specific number? It just keeps going up. Okay? So if I just keep holding this down, eventually it's going to get to 100, 1,000, a million. It just keeps going up higher and higher. And so that's why that limit is infinity. Right. This one says the limit as x approaches 3. We plug it in. 3 plus 3 is 6. 3 times 3 is 9, plus 1 is 10. Do I want to divide by the highest power of x in the denominator? Yes or no? Why not, Lizzie? Yeah, there's actually 2 reasons. First of all, this stipulates that x has to be approaching positive or negative infinity. This is not, x is not approaching positive or negative infinity. The other thing is, I have to get an answer of infinity over infinity before I do this. I didn't get infinity over infinity, I'm finished. My answer is 3/5. I'm done. See, that's the problem with calculus and all math. We learn how to do something and then we want to keep doing it on every single problem. That's not the way it works in calculus. They immediately start throwing in problems where you have to use different methods. So if we can plug in and we get that numerical answer, just like we talked about over here, we plug in the value, we get a number, then we're finished. We don't go any further. Okay? All right, complete the given table to estimate the limit as x goes to infinity. So because this function is kind of a strange function, and it's difficult to find that limit as x goes to infinity, I'm just going to type it into my calculator. I'll do a zoom set. Now, the question is asking me what's happening to x, or what's happening to the limit as x goes to infinity. I can almost kind of see it, but let's test it anyway. So they want me to plug in 10 to the 4th. If I try to plug in 10 to the 4th, my calculator says it's invalid. Why is that? Why won't it check 10 to the 4th for me? I gotta make my window big enough, guys. I'm gonna be checking 10 to the 4th, 10 to the 5th, and 10 to the 6th. I've got to make my x max big enough so that I can see all of that. So I'm going to make it go to 10 to the 6th. Now when I go second trace and calculate a value, and I want to find a value for when x is 10 to the 4th. Now it's not going to have any trouble with that. It tells me the answer is 0.01. And when I go to second trace to calculate a value at 10 to the 5th, the answer is 0.003. And finally, when I test 10 to the 6th, the answer is 0.001. What do you think this limit is then? What is the y value that we're approaching as x gets bigger and bigger? 0. Yes. That's our answer, 0. Okay, so that's a numerical approach. All these different methods. Okay, these last three we're going to save. We're going to do these for warm-ups on Friday. So we're going to stop there. So one more thing, guys. Just remember,